Okay, guys, we're on to 1.5 applications in modeling with quadratic equations. So this is the story problem version of our quadratic equations that we studied just in the last section. So the one I want to start with is number 24 in the book, and it's about the dimensions of a garden, okay? And it says that an ecology center wants to set up an experimental garden using 300 meters of fencing to enclose a rectangular area of 5,000 meters squared. Find the dimensions of the garden. And they even give us a little picture here, and they kind of give us a way to start setting this up. Now, if you're wondering where this 150 minus x and x is coming from, let's think about it, okay? If I have 300 meters of fencing and I need a rectangle, let's suppose I used 100 meters right here, okay? Well, I know this would have to be 100, right? And then that would leave 50 and 50. Well, what's 150 minus 100, the x value? That's 50. So this is just a relationship between two sides. If I call this x, then I have to take 150 minus whatever I used here. Why is it 150? Well, because if I take a width and I take a length, together they have to make 150 because it's going to be the same here and here. So that's the reasoning it's set up like this, okay? So let's go over here, okay? And I have this right here. Here's the setup they gave us in the book. And then I know that area is length times width, okay? And they told us the area is 5,000 meters squared. So I'll set that equal to the length times the width. Now I'll call the length that x value, and I'll call the width the 150 minus x. Once again, this is just saying, hey, these two have to add up to 150. So whatever I use here, I have whatever's left over out of the 150 here. So 150 minus what I use, that's the leftovers. So I have this equation, 5,000 is equal to 150x minus x squared if I distribute. And notice that now I have a quadratic equation. Okay, this is quadratic. So what I'll do is, let's get everything on the same side. Since x squared is negative, I think it makes sense to add x squared to both sides. And then I'll subtract 150x from both sides because we know the strategy is to get everything on the same side. And that's going to leave me with x squared minus 150x plus 5,000 is equal to 0. Okay? So if I can solve this for x, what is that going to give me? That's going to give me this length. And then this one's easy to find afterwards, okay? So you can use quadratic equation. That's fine. You could complete the square. Or if you're clever, you can notice that this thing factors like so. And then I have x minus 150. Okay? Oh, sorry. That's actually 50. So it's x minus 50. So either x minus 100 times x minus 50. Negative times negative is positive. 100 times 50 is 5,000. Minus 50x minus 100x is your minus 150x. So we have two cases. Either x is equal to 100 or x is equal to 50. Okay. Now, if we think about this, if x is 100, that means this side is 50. If x is 50, this side is 100. So actually, they're both sort of right. The biggest thing I wanted to know was the dimensions. So I know the dimensions regardless are 100 by 50 meters. Okay, so that's number 24. The next one I want to look at is number 14. Okay, so let's back a page. And it's looking at integers. Okay, number 14 says, find two consecutive odd integers. So it could be 1 and 3, 3 and 5, something like that, whose product is 143. Well, remember, product here means multiply. Okay. So if they're two consecutive means one after the other, but they're consecutive odd integers, okay? So if they're consecutive odd integers, I know they differ by 2 actually, right? 1 to 3 or 3 to 5. So if I'm going to solve number 14, let's choose the smaller of the two numbers to be x. And we could choose the bigger to be called x plus 2. Okay, so it could be 1 and 3, 3 and 5, just like we said. Alternatively, you could say x and x minus 2 if x was the bigger number. And what else did they tell us? Well, they told us that the product of these two numbers, these two consecutive odd numbers, is 143. Product means multiply, so that tells me this. X times x plus 2 is equal to 143, right? Then I think what I'm going to do is I'm going to get a quadratic out of this. This is a quadratic equation we're ending up with. So I will subtract 143 to both sides so that we can use our strategy. X squared plus 2x minus 143 is equal to 0. And now we just have a quadratic to solve, okay? Now, I don't think that is necessarily very easy to factor, although you may be able to see it. So if I don't know, then I'll bust out my quadratic formula, which says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And notice in our case, a is 1, b is 2, and c is negative 143. So if I start plugging things in, I'm getting negative 2 plus or minus the square root of 4 minus 4 times a times c. And notice c is negative, so minus a negative that we will be adding under the square root. And that's all over 2 times a, or just 2. If we simplify down a little bit, I'm getting negative 1 plus root 576 all over 2. And that's going to end up being negative 1 plus or minus 24 over 2, or negative 1 plus or minus 12. So it looks like x could either be 11 or negative 13. So there's really two possibilities, two sets of consecutive odd integers that multiply to 143. One of them, if I use the 11 here, is 11 and 13, and you can check that. Or it could be negative 13 and negative 11. That's what we get from this. Remember, I get the bigger number because this was x. The other one is 2 more. And notice that these do both multiply to 143. Okay, so that's number 14 on 1.5.